have to find the modulus of u, and then I have to show that the argument of u is negative 90 degree. So my first step is I want to solve the u. How do I solve? I introduce the conjugate, and you use your calculator. As you do the upper part, you do the down one, you should get minus 3i. This should be pretty simple for you. Then now let's go find the modulus. So to find the modulus, you can actually use the formula, or what you can do is you can do thinking process. Because this is only imaginary part, there is no real part, right? So the question is very basic. What I can do, I can just draw my real and imaginary, and I'm going to plot where is this negative 3i. Isn't negative 3 going to be here now? Because the coordinate is exactly 0, negative 3. So when I do this, when I go and draw my complex number, it is actually going to look like this part. What do you think the length is worth? Isn't it 3? So they want the modulus of u, which is simply means the length of that particular complex number from the origin. So modulus of u is 3. You know this by inspection. And then their next question is, they said find the argument of u. Argument means what? Angle. So how do I find the angle? If you are using the formula, you will actually find difficulty. Why? You're going to do tangent inverse. Your imaginary is negative 3. When you divide by 0, you won't get answer. Negative 3 divided by 0 is undefined. So your calculator will show math error when you try to solve it this way. So sometimes geometrical interpretation is very important in this chapter. So when I look at this, I know that I cannot go upward like this, because the answer is going to be more than 180. So you cannot do this. You know, right? Our argument always has a restriction in their angle. It is negative 180 to 180, and the 180 is inclusive. If you are not going to go up, then the only way is by going down. Can you guess what is this angle? Isn't it 90 degree clockwise? So argument of u is negative pi over 2. That's simple. But if you are not convinced of doing this for 4 mark, then you can choose a longer path. What is this longer path? You apply the formula that you have learned. See, I want modulus of u. So what I'm going to do, I'm going to put modulus here and here. And then I'm going to break it into 2 parts this way. And later, you apply this formula here. It's long. And of course, I'm not recommending this longer process of you solving. So you do 6 squared plus negative 3 squared square root over 1 squared plus 2 squared. When you solve, you will get 45 and then surd 5 down. So surd 45 divided by surd 5 is literally 3. You get the same answer, but isn't it? See, this answer of mine and this answer of mine is same, but one is longer, the other is shorter. Now how do you think they will solve for the argument? So to solve for the argument, you also apply the argument formula. You do argument of u, you write the argument here, then you break it. Argument u minus, argument 6 minus 3i minus argument 1 plus 2i. So when I do this, what will I write? Okay, let's follow what we did earlier, yeah? It is tangent inverse negative 3 over 6. So usually what I will do is I would want to see it geometrically. Where is this complex number actually? X is 6 and then I have a negative 3 here. So I know my complex number is down on the 4th quadrant. No way I'm going to go up to find the angle. So I will go down. And I know my angle here is going to be negative. So instead of confusing myself by putting positive and negative inside the bracket here, I always choose to sustain it as positive. I will make the adjustment based on my geometrical interpretation. So I'll just put a negative in front here. And then where is 1 plus 2i? In the first quadrant. So first quadrant I have no problem. I will do tangent inverse 2 divided by 1. You type this in the calculator and you're going to get negative pi over 2 as well. Similar answer. I leave it to you which technique you want to solve. Now second part. They say I have to find least possible value of modular z. What is the meaning of least possible value of modular z? That is difficult, so we choose the easier question first. What is modular z? Modular z means a length from reference point 0 0. Why do I say reference point 0 0? Because it's just z, x plus yi. I don't have any pairing for the x, I don't have any pairing for the y. So your reference point is always 0 0. So from this reference point 0 0, I want to know which one gives me the shortest distance towards my locus. So what is the locus in the question? Can you guess what is this? Anytime it starts with an argument, isn't it a half line? Okay, let's go and solve that first. So argument z minus 3i equals to pi over 4. So my reference point here is going to be negative 0, negative 3. How do I know this must be always negative? So I look for x plus yi here. That is the coordinate. That this part here must be x plus yi. I don't have any x, so the coordinate of x is 0. My y is negative 3, then done. So you draw 0 and negative 3. Negative 3 is going to be down here, and then you want an angle of 45, right? So when you do 45 degree here, you know that it is exactly the same like y equal to x. So if this is 45, the length between these two is same. So can you tell me what is this coordinate now? Isn't it 3 0? Okay, so far you're doing good. Now this is my locus point. The dark blue line is the locus. Let's change it into a different color. This one, half line, yeah, this way. So go back to this one. My reference point according to this is 0 0. Now from this origin, which locus point here, there are so many locus point on the line, right? But which one will give you the shortest length? Can I go and say it is going to be this one? Do you think this is the shortest length? Or is it this one? Is it this one? Which one? Which one will give you the shortest length? Or do you think it's just 3? So which one is going to give you the shortest length? What is another name for shortest length? Isn't it perpendicular? So you're going to try to find this one. This is the shortest length you are looking for. How do I find that? We enlarge the diagram so that you understand better. Okay. My aim is to get this. Initially, when I drew my half line, this is my 0 and negative 3. To draw, usually I draw a parallel line, right? And then I am going to put this as 45 degree. This is how you draw a half line. I think we are very familiar with this. If this part here is 45 degree, can you tell me what is this part? Isn't it 45 also? So can you see you actually got a right angle triangle here? What is the length of this part? 3. You are looking for this particular height or length, whichever way you say it, and you don't know what is this, and this angle here is 45 degree. So let me draw it in a easier manner. This is my 45, and I know that this is my 3, my 90 degree. This is the length I want. So to find this, you're going to use sine. So sine 45 degree is equal to L over 3. You look for the L, that will be your answer. Meanwhile, I erase. You try reading part 3. It's also similar, it's just that the locus is no more a half line, it looks very much like a circle. Can someone tell me what is the center for the circle? This is my circle. What is going to be your center? 1 plus I minus 3i. You substitute, you multiply them, you're going to get negative 3i and positive 3. So z minus 3 minus 3i, you rearrange, equals to 1. And that tells me center of the circle is 3 comma negative 3. Radius is equals to 1. We draw. Where is my 3? Negative 3 here. Equal distance. And my radius is going to be 1 now. So it's going to look more or less like that. Check the question. They want you to find the greatest length. From where? What is your reference point here? 0, 0. So you put your 0, 0 here. From this origin, which locus point here? There are so many locus points, right? I mean, points lying on the locus, right? Which one will give me the shortest length? I'm going to draw, you guess. Do you think it's going, this is going to be the greatest? Not shortest, yeah, greatest. Is it the greatest? Or is this the greatest? Or is this the greatest? Of course, the one that passes through the center. So what you do, first you find what is until here, and then you can just add your radius. Isn't this your radius of circle? You know the radius of circle is 1. So how do we find this part here? To find that, you know, anytime you create a 90 degree, isn't it easy? This is worth 3 according to this part. This is worth 3 as well, 90 degree. And use Pythagoras theorem, find 3 squared plus 3 squared. You're going to get that plus the